So we're just going to have a look at this idea of solving these mathematical equations or engineering problems using graphical methods rather than analytical. You can see here in this space diagram here, if you can imagine, I've got one barge that's being towed by two tugboats. Now in this case here, I'm just showing you a methodology, so I actually do not have any like force or any indication at all about the power being put out. All I'm trying to find out is the resultant of adding these two forces together. So if I'm going to actually use a force polygon method, here I've converted it to my free body diagram just to get rid of all of these little details that I actually don't need. So basically I've got my lines of direction, like the force direction, as well as the angles here as well from the horizontal. With the actual force polygon, like at this stage, if I was actually doing it as a direct calculation, I'd be setting up something like scale, where you'd say 10 millimeters is equal to 10 newtons, or whatever you want to actually say there. And then that'll allow me to actually measure my answer. So if this was to scale, I could actually see there, I have 40 millimeters, so I'm actually looking at 40 newtons there. Now what's important with these polygons is this actual distance. So I can see from this one here, I am actually 40 millimeters away from this force. So I'm just going to come up here and I'm going to just measure in the 40 and do a line there. Right. So you see I've just drawn a pencil line, so it's parallel to this actual force. I'm going to do the same on the other side. Here I can see that that is about 34 millimeters. Come down here, draw in the 34. Oh, did I draw that right? Let me just double check that. Yep. And draw that line in there. All right. So basically it's a mirror image of the forces that were actually there. Now, here's the easy part. By drawing a line here, that is my resultant force. So you can see here I can straight away measure the angle, the angle of the force to get that in there correctly, which is roughly at about 10 degrees there, or negative 10 degrees. And I can come back here and convert this force, the distance, if it was to scale, to an actual force of around about 52 newtons. Okay. Now you can see how quick that was to actually do using the polygon method, rather than going through and trying to do an analysis of the horizontals and verticals of both of these triangles and then trying to add those together. It's a lot more work to actually be done. If I was actually going to do, and I'll just quickly mimic this as well over here. So I've got a force like this and a shorter force like this here. If I was actually going to do a triangular method here, basically I know that this force is running in this direction. If I move it up here, it's still going to be in the same direction. So here's my horizontal. Got a horizontal line there. I know that this is at 30 degrees. Coming back here with my triangular method, I need to actually get my horizontal again in here. So I'm just going to draw a horizontal line. And now I know that this angle here is at 50 degrees. So I can come down, align that up, pick up my 50 degrees here, to a line down. Again, knowing that this line here is at approximately 40. Oh, keep that colour. There's that force. I have this force here. And my resultant will be here. So again, you can see with these, both of these methods, with the two forces, like working a polygon, it's actually quite easy to solve that very quickly with a scale. This one takes a little bit more work, and I did need my protractor to get my angles actually correct. But again, you can see by creating that force triangle, it's still a lot less work than going through and doing the calculations of finding out the two triangles to make it actually work. Simple, yes. Learn it, because you're going to find that these questions will come up in like a multiple choice question where it will ask you to actually solve it quickly on the paper. And this method is a lot quicker when you're looking at those sorts of styles of questions rather than doing the analysis another way. Thanks for listening, and talk to you soon.